Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL November 2021 paper 1. And today we will be solving question number 2 of this paper and you will be getting the links to all the previously solved questions of this paper and of the other papers in the description area in form of playlist. So without any further delay, let us start answering question number 2. The maximum mark is 9. And it says the function f is defined by f of x equal to 2x plus 4 over 3 minus x, where x belongs to the set of real numbers and x is not equal to 3. So part A, write down the equation of the vertical asymptote of the graph of f. The vertical asymptote will be that value of x which it cannot have. Why can't a function have a particular value of x? Because for that value of x, the function may be undefined. And why will it be undefined? Like in this case, if you have x equal to 3, the denominator will be equal to 0, which you cannot have. So x equal to 3, even this is given in your question that x cannot have a value of 3. So at x equal to 3, the function will be undefined. That will be the vertical asymptote of the graph of the function f. So we will be writing the equation as x equals 3. Okay. Always for a rational function expression, if you have to find the equation of the vertical asymptote, you equate the denominator to 0 and get the x value. Okay. For I, the horizontal asymptote of the graph of f. For the horizontal asymptote, we are seeing both the numerator and the denominator. They are linear functions, linear expressions of x. So that means the highest power of x is equal to 1 in both the cases. So we will be taking the coefficient of the x to the power of 1 term from the numerator, and that will get divided by the coefficient of the x to the power of 1 term of the denominator. So the equation will be y equals, this is 2, and the coefficient of x to the power of 1 in the denominator is negative 1. So it is y equals negative 2. So this is the horizontal asymptote equation. And this is the vertical asymptote. Okay. Subpart B, find the coordinates. That means we have to give both the coordinates where the graph of f crosses the x-axis. It crosses the x-axis means this is the x-intercept or the zeros. You have to understand that these, all of them mean the same thing. Okay. That means the y value will be equal to 0 because for every point in the x-axis, the y value is 0. Okay. So let us just write f of x is y. F of x will be the y value. So that is equal to 0. 0 equal to 2x plus 4 over 3 minus x. This is actually the bi part. So 3 minus x, and the fraction value is equal to 0 means the numerator is equal to 0. So 2x plus 4 equal to 0. So this gives us the value of x as 2x equal to negative 4 or x equal to negative 4 over 2, which is giving us the x value as negative 2. Okay, the y value has to be 0. So this is negative 2 comma 0. Okay. And I the y axis, this is the y intercept. Okay, so for the y intercept, the x value will be equal to 0 because every point on the the y axis will be having the x coordinate as 0. So this is the I, and this is y, f of x, or I'm writing y in place of f of x. It is equal to 2 times 0 plus 4 over 3 minus 0. So this is equal to 4 over 3. And x value is of course equal to 0. So it is 0 and 4 over 3. Little more than 1 because 3 over 3 is 1. So we have completed the first two subparts, but this question contains more subparts. So let us move on to the next subpart of this question. So this is subpart C, and it says sketch the graph of f on the axis below, and it contains just a single mark. This is the function expression. X equal to 3 is the vertical asymptote, y equals negative 2 is the horizontal asymptote, negative 2 comma 0 is the x-intercept, and 0 comma 4 over 3 is the y-intercept. So first of all, let us draw the asymptotes. So maybe over here is x equal to 3. So just a rough sketch. Or less 2.5 it is. Most probably it is 2.5, not 3. But anyway, so this is the asymptote line, but I have to, this is a continuous line, so I have to do some modification. So it is it this way. Okay. Now it's more like an asymptote line. And then we have to take another one, y equals negative 2. Y equals negative 2 somewhere over here. Okay. Now I have to just this one is 3 and this one is negative 2. I may write this as x equals 3 as well, and this one as y equals negative 2. Okay, and we are done with the asymptotes. Now coming to the intercepts, negative 2 comma 0 is the x-intercept, or the 0. So this is negative 2. and 0 comma 4 over 3, so this is maybe over here. Four over 3. Okay. So now it's just we have to draw freehand curves. Like this it will be. And this side it will be this way. So this is f of x equal to 2x plus 4 over 3 minus x. We have given the intercepts, we have given the asymptotes. So we have got 1 mark. Let us move on to the next subpart. Okay. The function g is defined by g of x equal to ax plus 4 over 3 minus x, where x belongs to the set of real numbers and x is not equal to 3, and a is also another real number. And subpart D says, given that g of x equal to g inverse of x, determine the value of a. So first of all, let us get the expression for g inverse of x. Okay. So in place of g of x, I am writing y. I'll be using the conventional way of getting the inverse function expression. So ax plus 4 over 3 minus x. And now we will be just interchanging the x and y position. So it will be x equal to ay plus 4 over 3 minus y. Now we may cross multiply and we will be getting 3x minus xy equal to ay plus 4. Cross multiply, or you may say that we are multiplying the entire equation by 3 minus y. Okay. So now this is, I can write this as y a plus x. I'm adding xy to both the sides. So plus xy and minus xy will be cancelling. And this will be ay plus xy. So it is y times a plus x. And this is, I am also adding negative 4 to both the sides. So 4 minus 4 will be cancelling and this side will be having 3x minus 4. I've just written the right side first and the left side later. Okay. And I can do that. We can do that because it is an equation. Both the sides are the same, have the same value. So this is y times a plus x equal to 3x minus 4. So we have the y expression as 3x minus 4 over a plus x, which is equal to g inverse of x. Okay. And now we are saying that g of x equal to g inverse of x. So g of x equal to g inverse of x. So that means g of x is ax plus 4 over 3 minus x. This is equal to 3x minus 4 over a plus x. Now, if we look at the left-hand side expression and the right-hand side expression, first of all, let us check the denominators. In the denominator, it is a number and then minus x. Over here also, the denominator of the right side, there is a number and a plus x. Okay. But if we just want to have a minus x, because we are having a minus x in the denominator of the left-hand side. So, if we try to get a minus x in the denominator of the right-hand side, then what do we do? Because we have minus x in the left-hand side denominator. We can multiply the denominator by -1, but we cannot multiply only the denominator by -1. If we want to multiply the denominator by -1, we have to multiply the numerator also by -1. So let us do that. Okay. So this can be, if after multiplication with -1, the numerator will be 4 minus 3x over negative a negative x. Okay, and since I'm seeing that ax, the term containing x, is the first term of this left side, so let me write it as negative 3x plus 4 over negative a negative x. Okay, so now this is plus 4, this is plus 4, and this is ax, and this is minus 3x. So we are tempted to write that a is having a value of negative 3. What about the denominator? See, the denominator is 3 minus x over here, and this is minus a minus x. From the numerator, we are getting a as negative 3. And from the denominator, 3 equal to negative a, that means a equal to negative 3. Okay? So a is equal to negative 3. But what if you cannot just see this similarity between the left-hand side fraction and the or rational function expression and the right-hand side rational function expression? Then what do? You go for just simple cross multiplication. I'm just taking this part, the original equation that we had written. So ax plus 4 getting multiplied with a plus x. So this is equal to a square x and plus ax square plus 4a plus 4x is equal to 9x minus 3x squared and minus 12 and plus 4x. Okay, so this is ax squared and then plus this is a squared x, this is 4x, so it is a squared plus 4x plus 4a, the constant term, equal to minus 3x squared, and 9x and 4x will be giving us plus 13x minus 12. Okay. So now if we equate the coefficients of x squared from both the sides, we get a as negative 3. Okay. If we equate the constant terms from both the sides, 4a equal to negative 12, so a equal to negative 3. We are getting the same value for a. And if we, in case we equate the coefficients of x, what do we get? Because it is an expression, so let me do this part. A squared plus 4 equal to 13, and so a squared is equal to 13 minus 4, which is 9. Therefore, a will be equal to plus minus 3. This will be giving you two values, but over here you cannot take the plus 3. Plus 3 cannot be taken. Minus 3 has to be taken, because if you equate the coefficients of x squared, or if you equate the constant terms, you are not getting equal to plus 3. You are getting only minus 3. Only if you equate the coefficients of x from both the sides are you getting both the values. One of them has to get rejected. A equal to 3 will be rejected. And the answer is a equals negative 3. Okay. So these were the four subparts of question number 2. And I'm Nilanjana Sanyal, an online IB Math ESL and HL tutor, and I tutor students from within India and outside India, and I'm starting my small group online tuitions for the IB Math ESL and IB Math HL students. In case you are interested in joining my groups, you may contact me. You are seeing my website link given, you are seeing my WhatsApp number given, you are seeing my email ID given. So you may contact me for more details. Okay? And thank you for staying with me till the end. We meet again in our next session, where we'll be solving question number 3 of this paper. So till then, bye.